Hi everyone, I'm Francis. You're welcome to the Trillionaire Math. In today's video, we will discuss how to find the derivative of a product function. On the board here, I have is a question that says find the derivative of x sine x from first principle. Here, to work this out, our f of x is equals to x sine x, the given function. Using the definition of limits, using the definition of derivatives, f prime, or change in x over change in y, is equal to the limit as change in x goes to 0, change in y over change in x, or f of x plus change in x minus f of x over change in x. So now we replace, for this function, f into bracket change in x will represent, for this function, f changing f plus f into bracket x plus change in x. That's what we'll have here. So this function represents this expression here. Okay, x plus change in x into bracket sine x plus change in x for our f of x, which is a given function, we'll have it represented here as x sine x. We'll bring down our minus. Okay, now our change in x will bring down our change in x also. The next thing will be we'll take the limits as change in x goes to 0 of this expression. But keep in mind, the sine x plus change in x is an identity, is a trig identity. Recall your compound or your double angle formula identity. So recall your sine double angle formula identity that says when I have sine A, sine B, it's equal to sine A cos B plus cos A sine B. Okay, so using that identity, this expression sine A into bracket x plus change in x works out to be sine x cos change in x plus cos x sine change in x. We'll bring down our x plus change in x here, and then we'll multiply our x plus change in x with our sine double angle formula sine identity. When we do that, okay, the next thing that follows is to bring down minus sine x minus x sine x here. Also, then the next thing is to bring down the change in x also. And we'll multiply this expression with this expression here. In fact, all of what we have at the numerator, I'll spare the details here. I believe you can do it. All of what we have at the numerator here works out to be this. Okay, what we have at the numerator here also. Now at the denominator, I have change in x here. So what I've just done is to factor in change in x, but factoring it in such a way that I would have it to be some identity, cos, which is cos change in x minus 1 over change in x. We call this identity cos theta minus 1 over theta. I have written that identity out here. Cos theta minus 1 over 1 is equal to, when you take limit of this expression, as theta goes to 0, it works out to be 0. When you take limit as sine theta over theta goes to 0, it works out to be, the answer works out to be 1. Okay, so all of this expression here I have would work out to be 1. All of this expression I have here will work out to be 0. Keep in mind that when I put in cos as a value tend to 0, cos change in x will be equals to 1. And when you subtract 1 from 1, everything you have at the numerator here will be 0. So when you multiply out with this, you have 0. Divided by that change in x, all of that works out. This works out. Everything here works out to be 0. Okay? Now for this, because this is the identity I just mentioned here, this works out to be 1. Bring down x cos x here. S cos x times x times 1 will be s cos x. Here, I have change in x here, and I also have change in x here. Change in x can also change in x. I'm left with sine s cos change in x, and which is what that's what works out to be this expression here. Here I have change in x at the denominator, and I also have that at the numerator. They cancel out, and this expression works out to be cos x times sine x. Now keep in mind that as sine x, limit as change in x goes to 0, sine change in x will be 0. And that's what I have here. When I multiply that 0 times cos x, all of that works out to be 0. Okay? When I take limits of cos x as change in x goes to 0, cos x will be equals to 1. That's why I have 1 here. 1 multiplied by sine x, and that will be sine x. This expression is what I have here. All of this works out to be 0 at the end of it. And everything works out to be x cos x plus sine x. So when I find the derivative of this function, f prime, which is change in x over changing in y over change in x, will be equals to s cos x plus sine x. I believe, well, at this point, we've completed this problem. I would also go ahead and solve this problem using, a formula. Right now, I think we'll go over and solve the same problem using a product rule, yes. But before we use that product rule, we'll try to see how to find how to derive product rule. But either way, having used the definition of limits to find our dy dx, we can use this to see if we're going to get the same answer using the product rule. Okay, but all of this is geared towards making sure you have a lot of different perspectives to think about solving a derivative problem. Thank you very much for watching. I'll see you in the next one.